Hey guys, and welcome. In this video we're going to be doing 0625, which is physics, variant 43, October-November 2021. The time allowed for this paper is 1 hour 15 minutes, and in this paper we're going to be doing question number 10. Question 10, part A. A transformer has 500 turns on the primary coil and 25 turns on the secondary coil. The input voltage is 120 volts. Calculate the output voltage. So in this question, we're going to use the formula Vp over Vs is equals to Np over Ns, alright? So Vp, which is the voltage output, is 120 over X is equals to Np, which is the number of turns in the primary, 500, over 25, which is the number of turns in the secondary. Then X is equals to 120 times 25 divided by 500. This will give us 6. So the answer is 6 volts. Part 2. The current in the primary coil is 125 milliamperes. The transformer is 100% efficient. Now, as we know, milli means 1000. So we're going to do 125, and then we're going to hit divide, and then we're going to do 1000. Alright? So this is going to give us 0.125. 0.125 multiplied by the voltage, which is 120. So this will give us 120. This is going to give us 15. Now we need to divide this by the output voltage, which is 6, which is going to give us 2.5 volts. Sorry, 2.5 amperes. And the reason we did this all because power in the primary is equals to power in the secondary if it is 100% efficient. So we just use the formula P is equals to VI over here, and then we use the formula I is equals to P over V, which is being done over here. Part B. Figure 10.1 shows a loose wire connected in a circuit with a DC direct current power supply and a switch. The length of the wire between the two supports in the magnetic field of a horseshoe magnet. The power supply is switched on and the wire moves down. So the direction of the wire is moving downwards. These are the two supports, the wire in between, and this is the horseshoe magnet right here. And then we have the DC power supply. So part 1 says, on figure 10.1, draw an arrow on the wire to show the direction of the current. So the direction of the current would be determined using the Fleming's left-hand rule as DC power supply is given. When there's a DC power supply given, that means that we're supplying current, so current is not being induced. If current wasn't being induced, we'd use our right hand. Right now, we're going to use our left hand and make our fingers perpendicular to each other. Point our thumb downward and the index finger into the page, and the second finger shows the direction of the current, which is from right to left. Here's a picture on the side to give you an idea. Part 2. The power supply is switched off and the wire returns to its original position. The power supply is then switched on so that the current in the wire is in the opposite direction. State and explain what happens to the wire. The wire moves upwards as the current is reversed, so by the Fleming's left-hand rule, the force on the wire is opposite. You can even use your hands. You'll use your left hand, your index finger like the magnet, so you can see that if the current is going from left to right, okay, middle finger from left to right, index finger into the page, your thumb will point upwards. A split ring commutator is an important feature of a DC motor. So just one reason why the DC motor cannot operate without a split ring. So the answer to this would be that. So basically what unidirectionally means is that it will rotate in one direction. So if it's going anti-clockwise, it will keep spinning anti-clockwise as long as there is a split ring commutator. Thanks for watching and hope you found it helpful. Here are 2 other videos related to physics which I think you'll find helpful.